you? Ashok Rodriguez here of the Ford Engineering Team, and where did you bring us here? It's pretty cold and a lot of snow. What are we going to do here?
Yeah, so we're up at Smithers Scientific, and we're about to run some all-wheel drive lane change and slalom events. We're going to get a feel for the stability control system on the vehicle, how it helps us guide us through, as well as how the all-wheel drive system makes sure that we've powered the rear wheels so that the vehicle can turn in adequately and make it through a lane change and slalom type event.
Okay, and we are in a 2014 Ford
Escape? 2013 Ford Escape all-wheel drive.
Okay, let's try to see. I mean, I'm sure the car can do the things, but let's see how the driver can react to this thing. So we are simulating, you say, a lane change?
Right. The cones that are set up in front of us are for a kind of an emergency lane change. So we're going to start off at about the speed. We're about 20 miles per hour where we're at right now, and then we're going to accelerate, actually, as we go through the event to force that system to have to work harder.
To what, 30 or something?
Yeah, sure. Just do a moderate acceleration. And we can try it again at different speeds too, if you like. Now we're going to try a slalom event. So just powering the vehicle through the turn. You'll feel the brake system firing as we go through it. It's going to be basically pulling on those inside wheels in order to help us maneuver through the cones.
So this safety technology really helps the drivers, even if they're not as experienced in like difficult situations with
right, exactly.
weather conditions and all that. And I was pretty interesting to hear that you're selling a lot of cars not only in areas where the snow, the winter is with snow and all that, but also like in Miami, like where there's more rain than snow, but the system also works in those conditions.
Exactly. The ability of the all-wheel drive system to send torque to those rear wheels helps the vehicle not just from a traction standpoint, but also from a handling standpoint. There's a lot of sophisticated algorithms in the control system to look at where the vehicle's going versus where the driver wants it to go based on their steering wheel angle and other things.
I understand it's about 4 times faster than you can blink your eye.
Even faster than that. It's reevaluating conditions every about 16 milliseconds.
So let's say we lose traction on that wheel, so the system is intelligent enough to compensate that, moving the traction to the other side of the wheel. Right,
exactly. If it sees that we've lost traction on one side, it will immediately send traction back to either the rear wheels and or to the wheels on the other side of the vehicle. We've actually got 2 systems working. There's the four-wheel drive system, which is going to be biasing that torque front to rear, and then there's the brake traction control and stability system, which will bias the torque side to side. Both those systems are set up to provide handling, but they're also set up to they're both set up to provide traction, but they're also set up to provide handling to make sure that if you're even in a warm weather climate, that the vehicle feels much more nimble and will turn in crisply and react well to situations like this lane change.
So in fewer words, it improves performance and safety.
Right, it's providing traction and providing handling, so it's both for safety and for performance.
Excellent. So and the system is always on. You cannot take it. Turn it off, right?
The all-wheel drive system is always on. You can disable parts of the traction control system, the engine intervention part of that, if you are, say, for example, off-road. But if a situation like this, for maximum safety and stability, the system is just always on, always doing its thing.
So what happens if I suddenly brake really hard here?
Well, you'll get stability control and a combination of that with the analog brake system. If we're going a straight line here, just to make sure that the vehicle basically keeps going the way you pointed it, you've got your analog brake system working.
It's amazing how much computer ability can you put in a car. A lot of work behind that, right?
There's a lot of processing that's going on behind the scenes here.
It's not magic. How long that something like this is? I guess it's constant work because, I mean, you're always developing new things, but how long is a project like this?
Well, it depends. Some of the core technologies are developed kind of in an advanced system. And then about 2 years before a vehicle's launched, we start getting our first prototypes and applying the system directly to that and tuning it. So it's usually about a 2-year process before that vehicle is actually starting to get launched out to customer hands.
Well, excellent for the great job, and thank you very much for the opportunity of having us here.
Thanks.